Force causes an object to start moving, gain speed, slow down, stop from moving, and even change direction. These changes in motion is acceleration and is defined as the change in velocity per unit time. Balance force is attained when the resultant or the sum of all the forces acting to an object is zero. When the net force is zero, the object is under equilibrium condition. Equilibrium condition causes the object to retain its initial state of motion. Hanged objects stay in place because of balance force. Example, the weight of the bob is balanced by the tension offered by the string. The bob will remain at rest. Also, objects that are left lying on a flat surface will not move when Fnet is equal to 0. Example, the weight of the box is balanced by the upward normal force offered by the tabletop. This causes the box to remain at rest. What if we place a heavier bob while tension offered by the string had reached its maximum? The result is a resultant force that is negative. The forces are unbalanced. Fnet causes the string to snap and the bob to fall. What if we place a heavier load while the normal offered by the tabletop had reached its maximum? Again, the resultant force is negative. Forces are unbalanced, causing the tabletop to break and the load to fall. Now let's examine balance forces to objects with constant velocity. What happens to the motion of a ball that is rolling at a constant velocity on a frictionless floor if the net force is 0? As shown, the ball continues to roll at a constant speed in a straight line path because the Fnet is equal to 0. What happens to the motion of this ball that is rolling at a constant velocity on the frictionless floor if it is suddenly kicked with a force? As shown, the ball accelerates. The effect of unbalanced force to acceleration is summarized by the law of inertia, or the first law of motion. Objects at rest will remain at rest. Objects in motion will continue to move in a straight line path with a constant velocity unless acted upon by a net force. Inertia is the tendency of an object to retain its state of motion. For example, to dislodge a ketchup, you need to move the bottle with quick small thrusts so that the ketchup's inertia will change from at rest to in motion. The law of inertia is also observed in suddenly accelerating jeepney. The passengers are thrown slightly backward when the driver suddenly accelerates the jeepney. This is because the initial inertia of the passengers is at rest. Therefore, when moved, the inertia at rest tries to resist the change in motion. The law of inertia also explains why the jockey leans forward while the horse is galloping. This prevents the jockey to be thrown backward when the horse starts to gallop, and to be thrown forward if the horse suddenly stops. Which of the two boxes resists change in motion more effectively? The mass of box A is less than the mass of box B. Therefore, the inertia of box A is less than the inertia of box B. The quantitative measure of inertia is mass. The greater the mass, the greater is the inertia. Objects with greater inertia is more difficult to accelerate and decelerate. In summary, the law of inertia states that bodies retain their state of motion unless net external force is exerted on them. Inertia is the ability of an object to resist a change in motion. Mass is the quantitative measure of inertia. More massive objects are difficult to start and stop moving.